proxy will send all three credential types. So let's take a look at this a bit more because this is really important, especially with regards to performance and security when you turn on authentication in proxy. Now there are three types of credential. So you have basic, NTLM, and Kerberos. You can see that all three of them is enabled in proxy by default. Now basic is unsecured because it is using base64. And with that, you can in fact see username and password when you take a packet capture. But because you can, username and password is seen by the proxy can actually cache them. So even though it is not secured, but it is high performance because the proxy can cache the credential. The proxy need not to connect to the authentication server to validate credential unless the credential cache is expired. And NTLM is secured because there is no password sent across. It is a hash of the password, and it changes every time. But with NTLM, it requires more trip between the client and the server. Okay. We will take a look at the NTLM architecture in the next slide and find out what makes it not high performance type credential. And lastly, you have the Kerberos. So Kerberos is based on encrypted tickets, and it is high performance because it has lesser trip between the client and the server. High performance, secured in a way that Kerberos do not send password across. It is based on encrypted tickets. So we'll take a look at also Kerberos a bit more detail later on and understand how the proxy is configured to use Kerberos on both direct and the use of the agent. So NTLM, that's what I mentioned, it is secured but not high performance. Good thing about NTLM is that it is supported by pretty much any Microsoft production tools, okay? Streaming, any browsers are supporting NTLM. NTLM is a challenge and response type credential. So there are three messages type that will be sent: negotiate, challenge, and response. And all three of them will pass through proxy. And the last one of it, which is the response, since the proxy do not have the credential or the proxy will not be able to validate credential, then the proxy must send the type 3 response or message back to the user, back to the authentication server. So here is what it looks like. So when the user tries to access, proxy will authenticate, challenge the user for authentication. The user will send a type 1 message, which is the negotiate, okay? And after that, the part 2 message, which is the response, all right, challenge. And lastly, you have the type 3 message, which is the negotiate. Okay? And the type 3 message must be sent to the authentication server so that the authentication server can validate it. The proxy is not able to do that because the proxy do not have the credential of the user. So hence the proxy will not be able to validate type 3 messages. So as you can see, it is a bit lengthy with regards to NTLM. Okay? And since type 3 message will have to be sent to the domain controller, this connection between the proxy and the domain controller is limited by default. Okay? And because it is limited, then that is in fact the limiting factor, of course, because especially if you have large user base. Okay? Now, as what you can see in the proxy, let me just quickly show it to you. The maximum number of S-channel connections that the proxy will use to send type 3 message to the server is only 2. All right, so there are only 2 maximum S-channel connections that will be sent by the proxy to the server. not because the proxy only supports 2. So as you can see here, the proxy can go all the way up to 150 connection. But the limitation is not on the proxy side. It is on the server side. Because by default, the AD server will only accept 2. All right? So if in order for you to increase it, you need to, in fact, edit the registry file of the Active Directory to increase the value. Okay? So once you increase the value, so maybe you double it to 4, then you can increase the value at the proxy as well. Okay? So that is, how to fix the limitation of the number of S channel. Now, in proxy, you are able to find out if, let's say you're using S channel or you're using NTLM, and on the same advanced URL that I showed you earlier, you can find out the S channel latency. As you can see here, you can take a look at the failed authentication, especially if you're using NTLM, and the average latency. So that NTLM is secured, no password being sent, less efficient because more trip between the client and the server. Okay, it has an S-channel limiting factor that also needs to be considered with regards to performance. And next one is the Kerberos, right? So Kerberos is, as what you have seen earlier, it is the best of both worlds, right? It is secured because it is using encrypted ticket, okay? That's why it's secured. It is efficient because it has lesser trip between the client and the server. All right. So with that, let me show you, or let me just do this. Give me a second. Okay. So let me just explain this Kerberos a little bit. Wait a minute. Okay, so let me just use this. Paint. Okay, so what is Kerberos then? Kerberos is actually came from Greek mythology. All right. Kerberos is actually come from Greek mythology. It means a three-headed dog. That is what Kerberos. So that is what meant by Kerberos, a three-headed dog. Okay, so with Kerberos, right, this is how the architecture looks like. So basically, of course, you have the user, right? So you have the user, and you have the server. Okay, and let's say you have your proxy. All right, so this is your, in Kerbros, this is what you call your okay, so this is your server. In Kerbros, this is what you call your KDC, or Key Distribution Center. All right, so in Kerbros, this is your KDC. You have your, it involves what we call authentication server, right? It also has ticket granting server. All right, so this is your client. Okay, and this is your, let's say this is your proxy. All right, so basically in our application, what happened is the client, of course, wanted to access the internet. So in order for the client to access the internet, it has to go through proxy. And the proxy, in fact, is asking the client to verify that he is, in fact, a trusted client, right? So first thing first, the client, of course, will need to will then try to authenticate himself to the server. Right? So the client will connect to the server to authenticate himself. All right. So basically, what the client is doing here is that the client will encrypt his username with his password, and then it will send it to the server. So it encrypts his username and with his password and send it to the server. So this is your key, your first key. All right. The user password will use to encrypt the username. Of course, the authentication server knows what is the password of the client, right? This is your AD server. So the authentication server will be able to decrypt the username if of course, the client supply the correct password, right? So it's able to decrypt the username, and it will be able to verify if the user is in fact an authenticated user, right? And the next step is the authentication server will ask the client, will provide the client with a token, okay, to ask the client to ask or to ask the ticket granting server for a ticket, right? So it sends the client with a token, right? That token is encrypted. Okay. Now the client needs to have a ticket, so it needs to ask the ticket granting server. That ticket will be used by the client to present it to the proxy. So what happens next? So the client this time will connect to the ticket granting server, all right, with the token. Okay, so it will connect to the ticket granting server with the token. That token is encrypted, right? So it is encrypted by what? It is encrypted by the key, which is a second key known only between the authentication server and the ticket granting server. All right? Since the ticket granting server has the key, it is able to decrypt the token. So the client is asking the TGS that he wanted to access the internet via proxy. Okay? So the TGS will issue the client with a ticket. All right? So this is the another token or ticket. So now the client will use that and send it to the proxy. So the client needs to verify, validate himself to the proxy. All right? So when the client send it to the proxy will then uses the key which is known only to him and to the TGS, right? And this is your third key. Okay? So now since the proxy knows that the client is in fact trusted and validated using the token, then the proxy will be able to find out that the client is in fact a trusted client, and it checks the policy. And if the policy says the client is able to access the internet, it goes out to the internet, retrieve the content, right, and send back the content to the user. Okay, so that is Kerberos. You have the three-headed dog. So this is the first head of the dog, right? The key number 1. This is the password that will be used by the client to encrypt his username. And when the client asks for tickets from the TGS, it sends the token coming from the authentication server, the TGS is able to decrypt it because it shares a key number 2, with the AS. The TGS reply back with a token or a ticket to the client that is encrypted by the third key, right, known only to the TGS and the proxy. So when the client submits that, the proxy is able to decrypt it because of this third key. Right. So that is how Kerberos works. Okay, the three-headed dog. This is the first head, the key number 1. The second head, key number 2, and the third head, key number 3. Okay. So now in our how does it look like? Let's say we are using IWA Direct. So for IWA Direct, this is how it looks like. Okay. Of course, there should be a back-end configuration necessary first. Okay. So after back-end configuration is done, which I'm going to show you in the next slide. So this time, the same as what I've shown you earlier, the user will try to access the internet, right? So it will request for, it has to authenticate himself to the AD. It will request for a ticket, submit that ticket to the proxy. Because the proxy is a member of the domain, means to say it is trusted by the DC, the proxy is able to decrypt and find out that the client is a trusted client because it shares the negotiated key with the domain controller or specifically the ticket granting server. Okay, this is the third key here. Right, so IWA Direct is quite straightforward because the proxy is already trusted in your domain. Okay, configuration-wise, basically you just have to enable Kerbros, which is enabled by default anyway. So the DNS is important for Kerbros, so it has to use the private DNS. Now, in order for Kerbros to work, you need to set the browser proxy configuration to use the DNS name. So you cannot use IP address anymore for Kerbros. If you're using PAC file, the proxy that you use in your PAC file must use the proxy's DNSA record, not the IP address of the proxy. And if you're using transparent, you cannot use the default virtual URL anymore, and hence you need to use the proxy's DNS name. Okay? No additional configuration is necessary because the proxy is already a member of the domain. Okay? Now, how about if I use the agent? For the agent, it's slightly different because the proxy is not trusted by the domain controller. The proxy is, in fact, only communicating to your BCAAA server or BCAAA server. So, in a nutshell, the same process is happening, right? The same process is happening. The client will access the internet. The proxy will then challenge the authentication. It will ask the domain controller. It will authenticate itself to the domain controller, ask a ticket from the TGS, submit the ticket back to the proxy. The proxy needs to open the ticket, and because the ticket is in fact encrypted by the third key, known only to now between the proxy and the agent, not the domain controller. Okay, so that ticket will be sent, encrypted ticket will be sent by the proxy to the agent. Okay, so when the proxy receives a ticket from the client, the proxy could not decrypt the ticket, right? Why? Because the proxy do not have the shared key. Because the proxy is not a member of the domain. Who has the shared key? The BCAAA server. So it sends the ticket to the BCAAA server. The BCAAA server has that third key, is able to decrypt it and validate the credential. Then the proxy will receive an authentication response from the agent saying that the user is validated. Proxy checks policy, and based on policy, retrieve content and respond back to the user. So the only difference is that you have now the agent in between. Configuration-wise, there are additional configurations. Okay? So what are those? So same thing, Kerbros must be enabled. also create a DNS record for the proxy. And this time, you need to create a domain user account for the AD server. Now, when you install the agent at the server, you can actually use the local system user when you install the agent. But if you turn on Kerberos, you cannot use the local system account. You need to use a domain user account for your BCAAA agent. Okay, there are a few things also that needs to be configured, such as you need to have full access to the BCAAA directory, and then you need to configure the server where you install the agent, and configure the security profile to act as part of the operating system. And as I mentioned, you must log on to a service. Your agent, you must log on to a service. You need to use the domain user account to log on as a service. And lastly, you need to register the service principal name for the proxy. All right. Now, we are doing this because the KDC needs to know where is the service run. So it runs on your proxy, right? Meaning to say, if you have 10 proxy, you need to issue set spin for all 10 of your proxies. Okay? So you have to set spin and then -A, add, and then put the FQDN of your proxy and then the credential. Right? So you need to register all 10 of your proxies. So basically, that is with the agent. So additional configuration necessary if you're using an agent. So if you compare Kerberos and NTLM, so security-wise, both undoubtedly secured. Right? They do things quite differently, but both are secured. Performance-wise, we know Kerberos is better than NTLM. Right? Lesser trip than NTLM. It is also not bound to S-channel congestion, Kerberos. Configuration-wise, then, of course, Kerberos requires additional configuration. NTLM is like, could be it's like a plug-and-play type credential, right? It's configure and it will work. That is NTLM. Okay, so Kerberos additional configuration is necessary because Kerberos could fail in many different, not many, but several different reasons because it also depended on the client. That is why, if you notice, right, that if Kerberos is selected, the NTLM is default selected. You cannot uncheck NTLM if you enable Kerberos. Because if, for some reason, missing configuration on the client side, okay, or other reason, which is typically missing configuration from the client side or misconfigured, it will fall back to NTLM. That is what will happen if Kerberos is not negotiated. Okay, so that's what you can see here. NTLM, you cannot uncheck if Kerbros is checked. All right, so with that, let's go ahead and do our next lab exercise. So this one is using understanding authentication credential. We have 2 labs for this. Okay, 2 labs for authentication credential. So I'm going to stop the sharing now, and I'm going to take you to it. So 2 labs.